Let's talk really quick about the proof. This is on your notes, page 3. And if you want to first just kind of sketch y equals e to the x is an exponential function. So it contains the point 0, 1. And we talked about this before, that the slope of this line at 1 is equal to 1. That's kind of what makes this special. And then at the coordinate x, e to the x, what you'll notice is the slope is e to the x. And that's why the derivative of e to the x is still e to the x. Okay, let's talk about the proof. So we're just going to talk about the limit using the limit definition that we did last chapter. And what we're going to plug in is our e to the x. We're going to plug in for our x. So we're going to have e to the x plus h minus e to the x all over h. And then what we can do is we can combine exponents, or actually we're going to factor out an e to an x. So remember, when you multiply, you add exponents. So e to the x times e to the h, if you multiplied that, that's how you get back to e to the x plus h. And then e to the x times 1, that gets you back e to the x. And we still have this over h. And then let's think of what happens as h approaches 0. Well, what I did here is I factored out an e to the x. And then the limit as h approaches 0 for this, we're going to have 0 over 0. And I have a rule that this equals 1. That must be a rule, if you look in your book, that this is going to equal 1. And so that leaves us with e to the x. So it's kind of a silly proof, but that's the proof. Okay, and then what I want to talk about is on the back page, number 10 and number 11, or actually, sorry, number 11 and number 12. So if you want to try to figure these out on your own, that's fine. But what you're trying to do on number 11, find the equation of the tangent line to the curve y equals x to the 4th plus 1. Ooh, that's parallel to the line y equals 32x minus 15. So if you guys remember, parallel lines have the same slope. So basically, we kind of want to know when the slope of the tangent line is equal to 32. So first, let's find the derivative. 4x to the 3rd will be our derivative. And we basically just want to find when that is equal to 32. And we can just solve this, divide by 4, 8 equals x to the 3rd, and then the cube root of 8 is equal to 2. So x equals 2, and it has to be positive 2, because negative 2 cubed would be negative 8. So just x equals 2 is our only answer. So what we're trying to find here is an equation, though, of a line. So we know that the x value is 2. I kind of want to, I'm going to type this into Desmos to show you guys what it looks like, but I'm going to go ahead. All right, I looked at Desmos really quick. So x to the 4th plus 1, this is our original function. We're trying to find a line parallel to 32x minus 15. And that tells us basically the slope has to be 32. So we took the derivative, set it equal to 32, and we found x equals 2. So going back to the original function, it kind of looks like a flattened parabola. And the point 217, so if you plug a 2 into this, you get 217 is this point, and we're trying to come up with the equation of this tangent line. Well, we know the slope is 32, and so if you remember the formula y minus y equals m times x minus x, I guess y1, x1. So y minus 17 equals the slope, 32, times x minus 2. And then you can just kind of get this into slope-intercept form. And then I'm going to add the 17. So y equals 32x minus 47. And if you would type that into Desmos, you're going to see that line is going to hit exactly at the coordinate 217. And you're going to see that it's parallel to the original line of y equals 32x minus 15. So that's kind of an interesting problem. Okay, number 12. This one's a really cool problem. And you might want to graph your original function, x squared plus x, is just going to be a parabola, and it wants you to find the equation of both lines through the point 2, -3. So let's just go ahead and graph the original parabola first. All right, so this one's tricky. So here's our parabola, and here's the point 2, -3. So what's going to happen is we're going to end up being able to make two tangent lines. This one's going to be probably pretty steep and kind of, you know, maybe hit the parabola right there. And then this one's going to be somewhere this way and hit the parabola about there. So we're trying to find the equation of both of these lines. So how are we going to do that? What we're going to do first, you probably guessed, is take the derivative. Oh, take the derivative of this. So that would become 2x plus 1. That, remember, is the slope of the tangent. I'll say tangents. So you can tell by looking, the slope of this tangent line is different than the slope of this tangent line. But what's cool about the derivative is this describes the slope of this line, and this describes the slope of that line. Okay? Here's how that's possible. We're going to do, let's start with, which one did I start with? Oh, I guess it doesn't matter. We're going to do the point slope form. So we're going to do y minus -3, so it'd be y plus 3 equals the slope times x minus 2. Well, our slope is this for any given point because we don't know exactly where this tangent's going to hit. We don't know exactly where this tangent's going to hit. So I'm going to plug in this for slope. And then I'm going to FOIL. And then I'm going to subtract this 3. Oh, sorry, this is a -2 right here. This becomes a -5. Okay, so what we're interested in now is, oh gosh, we're interested in where this, that's a parabola, but this parabola is going to show us where this point hits the curve and where this point hits the curve. Okay, so we're going to look and see. I'm going to go over to Desmos and type this in. All right, I should have been prepared, but I'm not. It's okay. So we have 2x squared minus 3x minus 5. Okay, and this intersects right here at -1, 0. So that is this point. It's pretty close on my guess. And then we're going to have to zoom out a little bit. Let me hit my minus sign. A little bit more. They are going to cross, I promise. Okay, right around here. There it is. At 5:30. So that point is up here. So all you have left, I hope you can finish it, is you are supposed to find the equation of both of these lines. So find the equation of this line and find the equation of this line. And then you will know if you are going to know you're right when you type that into Desmos. So I'm going to get rid of this parabola. That parabola just helped us find those points, but those were not lines. So your goal is to find the equation of both of those lines that would hit the parabola this way, and then the one that would hit the parabola that way.